Okay, now we're ready to look at our second issue in exponential smoothing. And let me run through these very quickly for you. We'll get to where we want to be. All right, so if you'll remember now, exponential smoothing, it's a simple mechanical technique. And we've already looked at single exponential smoothing. You can see me pointing here. And single exponential smoothing works when basically we have no seasonality, whether that seasonality is additive or multiplicative, and we have no trend, whether that trend is an additive trend like this, as you can see here, or a multiplicative trend like this one. So single works best here. Easy to do in Excel and easy to do in Minitab. Now we're going to move to our next technique. This is Winter's method, oftentimes called double exponential smoothing. And one of the things about these smoothing techniques is they have all kinds of different names associated with them. There's not just a single name. So this is Holt's linear method, and it deals with trend, and we can have Holt's additive method, and we have Holt's linear trend, trend method. Now, what's important here, again, is to realize that this is mechanical. So I can only use this trend method when there is trend. If there is seasonality in addition to the trend, I can't use this method. So let's look at it. It's used for data exhibiting a trend over time. Okay, no seasonal pattern. That's a little bit more complex than what we saw, and I'll show you that in a minute. And the complexity really essentially revolves around, one, the level issue that we saw in single exponential smoothing, and now, of course, adding in the trend. That's the other additional complexity, okay? So now let's just kind of look at how it works. As you can see here, I'm pointing to FT. This would be our forecast. Notice again, this is our familiar smoothing constant. This is the last actual data observation that we had. So in this case, let's say this is January of 2014. Then the last actual sales data that I probably have that's complete would be December of 2013. Now notice, this is the difference between, when we were looking at single here, we had forecast error here. But notice now, when we're looking at double or Holt's exponential smoothing, we have the original forecast, but now notice we've got this new complexity added, a trend, okay? So that's the principal difference, okay? Notice no seasonality. Now the question is, how do we look at putting the trend in? In Holt's method, it's very simple. It really consists of two parts. A weighting method of the forecast one period ahead and the forecast behind, so the forecast error, and then a weighting scheme on a measurement of the trend. So basically now what we have then is this value here, okay? This value here is determined by this equation here. This, of course, is your last actual forecast. This is the only really tricky part, as you can see here, and it's simply the number of periods into the future that we're going to forecast from the last actual value. So again, putting all of these together, again, just so you understand conceptually what's going on, that's what's happening. What's happening? We're forecasting level very much the way we did in single, but we've added in a trend parameter, and then we're going to push that trend parameter this many periods ahead into the future. It's essentially that simple. Now, in real life, in terms of actually doing this kind of forecast, you don't have to do it. Excel has what's called double or Holt's exponential smoothing technique, and Minitab also has one for you. So that in Minitab, essentially, what we'll do, and I'll show you in a future session or show you in class, online or face-to-face, we'll go through and essentially then do it in Minitab. What we would do is is go to statistics, we would go to time series, we would go to double exponential smoothing, we would click on the data that we want to use, the single series we want to use, and then what pops up is the opportunity to use something called optimize, and then Minitab and Excel will pick the alpha value, that's one smoothing constant, and the beta value, the second smoothing constant, to minimize the in-sample forecasting error, and then use that weight to forecast ahead into the future. So again, it's essentially that simple. Now, as a rule, just like with single exponential smoothing, these smoothing constants range between 0 and 1. Large smoothing constants are troublesome, and small smoothing constants are troublesome. And just as I had mentioned to you when we were looking at single, again, values that range from about 0.02 to 0.3. Some people even say you can have a smoothing constant as high as about 0.5 and without any problem. And there's a little debate on that. But again, we would essentially apply those same criteria in terms of how high or low the smoothing constant is. And again, a smoothing constant that's too small is not acceptable, and a smoothing constant that's too large is not acceptable. And if we were to go back just quickly, and let me show you, okay. All right, notice, let's look here. This is our our single exponential. Notice the trend is missing. You can sort of see the common sense of this, that if I had a smoothing constant, an alpha value that was as large as 1, then 1 minus 1 is 0. So essentially I'm saying I'm making no forecasting error, and I'm essentially putting all of the weight in terms of my future forecast on the last actual value. That really doesn't seem to make good common sense. And if I had a smoothing constant of 0, then basically it says, excuse me, it says, I don't care what my last actual value is. Again, excuse me, I'm going to put a great deal of weight on my last forecast. So that's kind of the intuition behind why we don't like very large smoothing constants and why we don't like very small smoothing constants. So just that simple. Now, when we get together next, we're going to look at what's called Holt-Winters, or a 3-parameter exponential smoothing model, where we account for level as we did in single, we account for trend as we did in, we'll come back one, as we did in Holt's, and then we're going to finally add in the issue of seasonality. Okay, so we'll look at that next time.